Now the IRS, or also called the RSAT, Remote Sensing Satellite, is a part of India's dual satellite system along with GSAT, that is the Geosynchronous Satellite System, or also called INSAT. Now these are the two main satellite systems of India, each serving a different or a specific purpose, and it is mainly the purpose on which these satellite systems are divided. Now in this video we'll be looking particularly at IRS, which is the Indian Remote Sensing Satellite. So we'll first be looking at the mechanism of its operation, and this will be the second part of the video. Before that, we need to see what basically is IRS, and that is what is an Indian Remote Sensing Satellite, and then we'll see application or utility and finally some facts related to IRS. Now, coming to the first topic, that is what is an IRS. So we need to see the full form, that is Indian Remote Sensing Satellite. Now this is what it is. In order to understand what is the remote sensing satellite, we need to know what does remote sensing mean in the first place. So remote and sensing. Now again breaking down the term, we see what is sensing. Sensing is nothing but sensing whatever it means in English, that is, to see or to find or to chart or map. You get the idea. And then remote. Now what could remote mean over here? See, doing all these activities from a remote location, that is from an isolated and aloof perspective. To give you a contrast, see, in a laboratory experiment, you are part and parcel of the experiment because you are very much involved in it, and things proceed as and when you want them to, or as and when the reaction or whatever it is that is taking place happens. So here there is an involvement and you are an active participant in whatever is happening. In contrast to this, the remote sensing researcher or scientist sits alone and observes what is happening. This is what remote sensing is in a nutshell. So he watches the whole event from a bird's eye view. And that's about it. So here we have an isolated and a more aloof observer collating the data. Right. So in that sense, what does an IRS satellite do? It does the same. That is, it provides remote sensing data to Earth, right? And hence it is also called space-based Earth observation system. Now this is very important. This actually defines what an IRS satellite is: space-based Earth observation system. So that's about it, defining IRS. And when we'll be further looking into the mechanism and the domain of application, we'll see this definition or this meaning of remote sensing satellite will further be refined and enriched. So coming to the mechanism of its operation, mechanism of IRS. So like any satellite, the remote sensing satellite has to be placed in an orbit around the Earth. Now which orbit? In an orbit. Now which is that orbit in which it should be placed? As you know, we have many orbits around the Earth. The LEO or NEO, which is the low Earth orbit, or the NEO Earth orbit. This is the lowest orbit that there is, and we have International Space Station, Hubble Telescope, etc. over here. And then we have the polar orbit. Then we have geostationary or geosynchronous orbit. So these are the orbits that we have. So where should we place the remote sensing satellite? Now you see, every orbit that we have serves a specific purpose, right? And this remote sensing satellite accordingly has to be placed in this polar orbit. So there's a very these two are so interconnected that without polar orbit there would be no remote sensing, or without remote sensing there would be no polar orbit. This is how it is. So it is the position of the orbit that has come to define the remote sensing satellite itself. Now, so in order to understand remote sensing, we need to understand remote sensing satellite. We need to understand the polar orbit first. So what is the polar orbit? Polar orbit. Like I said, this is the second highest orbit. This is the second highest orbit after GSAT. So polar orbit has a height of 600 to 900 kilometers above Earth's surface. That is its radius. This is the radius, 600 to 900 kilometers. That's the radius. And then the other defining feature of the polar orbit is, supposing this is Earth, and say this is equator, 0 degree, and these are the two poles. Then the polar orbit has to be in such a way that the satellite crosses over the poles in each of its revolution. Crosses poles per revolution, and at the same time it should form a 90 degree or so angle with the equator. Now this is what basically the physical aspect of the orbit is. These are merely facts, but they are important because eventually, based on this location and profiling of the satellite, the functioning will depend. So having said that, we need to observe what it means being 600 kilometers at a 600 kilometers distance from Earth. So this means basically that that the velocity of this satellite is high and the time period per revolution is low. That is, it is moving at a very high velocity around the Earth, and is completing its one revolution within a very short time span. Now, to give us a fresh perspective and also to see how actually the whole movement is taking place, we need to factor in the rotation of Earth over here. Now we are looking at the mechanism of a remote sensing satellite and how it takes place, and then we'll be connecting this to the domain of or its area of application, which is what defines the remote sensing satellite or anything for that matter. So let's not be distracted. This whole thing that we're doing, that is incorporating the rotation of the Earth, is in order to understand the mechanism, and through mechanism we'll be better able to understand the domain or its area of application. So incorporating rotation of the Earth, rotation happens from west to east. west to east, right? Now the Earth is rotating like that, and this is the polar satellite orbit, and this is the satellite which is keeping on revolving around the Earth. So this is happening. So this was, suppose this is Congo, and over here, and this is somewhere around the equator, and it is ill. That's about it. Now after a certain period of time, as the Earth keeps on rotating, Congo is bound to come somewhere over here, right? And this will now be under the area of polar satellite, because Congo along with the Earth has shifted towards the east. So what I'm trying to say is, as the Earth keeps on rotating, almost every area of or region of the Earth is covered under this remote sensing satellite. So this is another defining feature of remote sensing satellite, that every region of the Earth is covered. Not like at a single time, not at a single time. It's not happening at a single time, but throughout a period of time. Say within 24 hours, when the Earth has rotated full once, then we'll be having a certain amount of data about various regions of the planet of Earth, and then again when another fresh rotation will happen, we'll be having more data. So this is the beauty of PSLV, that as it keeps on rotating, as it keeps on revolving due to its high velocity and short span of revolution, the entire Earth is covered irregularly at fixed intervals. So what does this mean? This means that this satellite is good at doing something that requires covering a region. So that means mapping, and now we're entering the domain of its application. So that was all about the polar orbit. So we covered over here polar orbit, the distinct features of this RSAT, and now we are getting into application part. So mapping, we understand why does that take place, because of the RSAT, and then on a related note is a reconnaissance activity, that is surveying the territory or arms and ammunitions of the enemy. See, it's basically this whole remote sensing satellite, it operates by forming an image through infrared radiation. So we are looking at images basically. That's about it. So when we say that we are surveying the territory of the enemy, there's nothing complicated about it. We're looking at images. So if we say that reconnaissance activity is happening, so anything related that you can find on a photograph, say the infiltration area of the army of the enemy nation, infiltration of enemy nation. So we can see the whole area under that. So infrared, this thing is the factual kind of a side note over here. And on a related term, I would also like to mention the SAR and active mapping. Now the IS is and good and suitable for its use as long as we have clear skies over the region. In case there are clouds, In case they are clouds, then we'll have a problem relating to this one, formation of images, because this whole remote sensing satellite is working on the principle of absorbing or taking it infrared radiation. But clouds actually reflect back or refract the infrared. So the satellite that is based over here won't be able to gauge the area, and so we can say that it is the cloudy skies or bad weather won't let the IRS function. So to help us with this problem, Israel gave us this technology called SAR, which is synthetic aperture radar. Which has enabled us to do what? Active mapping. That is, we are able to map the areas even when we have cloudy weather. This was one of the problems for India, because India is a land of monsoon. Right, during summers we have southwest monsoon, or almost whole of India, and during winters we have, say, disturbances in Punjab and northeast monsoon in south. So and moreover, as we'll see in a while, that this application IRS is needed for collecting agricultural data. Agriculture is a very important sector of our economy, considering the fact that more than 50% of the population is engaging in this activity. So this is a very important sector of the economy, and IRS plays a very crucial part in increasing the productivity, the acreage, preventing disasters, and other related things that have to do with agriculture. But however, the IRS won't be able to function when monsoon comes. That is during mainly Kharif season, right? Kharif season, IRS is not able to function. So the SAR made us do active mapping, and that allowed us to see through the cloudy weather also, and since then our problem has been solved thanks to Israel. Having said that, now let's again come back to the area of application. The second area that I've after reconnaissance would be agriculture, as mentioned before. Agriculture. Now agriculture is very important. The IRS data helps us to see the area under production. It also enables us to see area under pest attack. It allows us to measure productivity. It also is able to see the water tables, whether they are depleting or they are increasing. So this is important in that regard. It is like the IRS is used for drought. These things can be measured by other say instruments as well, but when we look at drought, and I believe 56% of the agricultural area in India is subjected to drought or is prone to drought, it is only IRS that can actually predict drought within a considerable period of time with its onset. See, the second ARC, okay, I'm sorry, just a second. So yeah, we were looking at drought. Now the thing about drought is that unlike avalanche or earthquake, it's a very slow set-in period. People at the ground level are not really aware if a drought is actually happening or not. So So even if we have a drought creeping in, people won't be able to tell because it has a very slow setting time period and is generally not observed till it becomes severe. Not observed till it becomes severe. So this is the problem with drought. But the IRS and even second ARC in its report on disaster management says that the remote sensing satellite plays a pivotal role in preventing droughts because the IRS gives us a bird's eye view of the picture. So if we have falling productivity and falling groundwater tables and other things that are happening, so we can have a bird's eye view of the whole region, and we can see that there's a drought which is creeping in. So it's more easily noticeable, and the first step towards prevention of any towards management of any disaster is to prevent it from taking place. That is preventing a hazard from becoming a disaster. So preventive measures can be taken, and at the same time, if disaster is already going to take place, then we can better prepare the community, and we can take such other measures as are necessary. Government can provide relief, etc., etc. So IRS plays a very instrumental role in agriculture sector. That said, now it is also pivotal role in mineral prospecting. Mineral prospecting is when you're trying to find out minerals that are there. But I'm not sure if the hydrocarbon fields or the oil wells are also if they are also done by IRS satellites, because if that is so, since we have 75% of our oil fields unexplored. So if at all the IRS is doing this exploration of the oil fields, then considering the fact that we have 75% unexplored oil fields, IRS would play a very pivotal role in the development of not just industry but also the hydrocarbon sector, that is the petroleum industry. So we just saw that agriculture it helped the agriculture sector. Now it is also helping the industry in terms of mineral prospecting. Industry also needs water and other things, so it's all related that IRS does, the remote sensing satellite. Fifth is we can do coastal studies, fisheries, and you can also study climate change. You can find out about shrinking glaciers, rising coastal waters, submergence, etc. So also we have incorporated this disaster management aspect into the growth and development of a nation. So we can very well see that the Indian remote sensing satellite has come to play a very important role in the socio-economic development of a nation. So and at the same time, one last application is that it can be used for urban and rural planning. And the fact that we have a bird's eye view of the whole thing, or we have a larger picture there with us. So infrastructure projects can be better planned. Canals and road and other things that are there to be planned can be done when we have a larger, or when we have a bird's eye view of the whole, say, city or the village or area, any area under consideration. So urban and rural planning can be done. So again, we see that IRS, Indian Remote Sensing Satellite, is contributing to the socio-economic development, and in that regard it is very important. So conclusively, yeah, so some facts, like I said, having finished the third part, the last part would be some facts. And it's nothing but say some of the important IRS satellites are Cartosat, which is nothing but cartographic to satellite, so this is indulging in cartographic activity. Then we have ResourceSat, which I believe measures the resources available in India. Then we have OceanSat. These are some of the IRS satellites that are there, and that's about it.